Here we have a SAT math problem. Okay, let's go to the question. In the right triangle ABC above, AB equals to 9 and BC equals to 12. If D is the midpoint of BC, what is the area of triangle CDE? Okay, here we have to find the area of the triangle CDE over here. Okay, now let's consider the two right triangles in the given figure. That is the right triangle ABC over here and the right triangle CDE over here. Okay, at the vertex B of the bigger triangle, we have right angle. At the vertex A of the smaller triangle, we have right angle. And C is a common vertex for both the triangles. So that is the angle, interior angle at vertex B in the bigger triangle, interior angle, the vertex C in the smaller triangle are equal. Both of them are right angles. Since C is a common vertex for both the triangles, interior angle at the vertex C for the bigger triangle ABC and interior angle at the vertex C for the smaller triangle are equal. Okay, here we can consider the two interior angles at the vertices B and C of the bigger triangle ABC. They are equal to the interior angles at the vertex E and vertex C of the smaller triangle. Since the two interior angles of the bigger triangle ABC are equal to the two interior angles of the smaller triangle CDE, by angle similarity postulate, the two triangles are similar. Okay, now let me write the vertices in order. Okay, let me take the vertices in the bigger triangle ABC, in which first let me take the vertex B over here. And now let me consider corresponding vertex in the smaller triangle. So that is E, because at vertex B and vertex C, we have right angles. Okay, let me write over here. And now let me write the vertex C in the bigger triangle. So because C is a common vertex for both the triangles. So let me write C for this one as well. Okay, now the third vertex for the bigger triangle is A and the third vertex for the smaller triangle is D. So these two triangles are similar. Now what we have to do is we have to get the ratio of the corresponding sides. For that, we can mark the given lengths over here. So the length of BC is 12. Okay, let me mark 12 as the length of BC. And D is the midpoint of the side BC. Since D is the midpoint, this midpoint will divide this length 12 into two equal parts. That is the length of BD is 6. The length of DC is also 6. Okay, and also the length of AB is given. That is 9 over here. We can mark this 9 over here as the length of AB. Okay, here using the length of AB and the length of BC, you'll be able to get the length of the hypotenuse of the bigger triangle AC. Okay, how do you have to get? We can use Pythagorean theorem. However, there is an easy way to get the length of this hypotenuse AC of this right triangle ABC over here. How do you have to do that? When I consider the lengths of the two legs AB and BC, here the length of AB is a multiple of 3 and the length of BC over here is a multiple of 4. Apart from the hypotenuse AC, in the remaining two legs AB and BC, one of them is a multiple of 3 and the other one is a multiple of 4. So this right triangle ABC may be a 3, 4, 5 right triangle. So for that we can write this 9 as a multiple of 3, that is 3 times 3. And we can write this 12 as a multiple of 4, that is 4 times 3. Okay, here the lengths of the two legs AB and BC are the multiples of 3 and 4 with the same factor 3 over here. Since the lengths of the two legs AB and BC are the multiples of 3 and 4 with the same factor 3, then the length of the hypotenuse AC must be a multiple of 5 with the same factor, that is 3. Then the length of the hypotenuse AC equals to 15. Okay, now let's come to this stuff over here. As I said earlier, the two triangles, the bigger triangle BCA and the smaller triangle ECD are similar. Now we have to get the ratio of the corresponding sides. For that, let's consider the smaller right triangle over here. In this smaller right triangle, we have the length for only one side, that is CD, that's length is 6. So we can consider the side CD of the smaller triangle. And what is the corresponding side in the bigger triangle? That is CA. So that is CA to CD. So the ratio of these two sides will give the ratio of the corresponding sides of these two similar triangles. Okay, just now we got the length of the side CA in the bigger triangle, that is 15. And the length of the side CD in the smaller triangle is 6. Now we can simplify this ratio. In this ratio, both the terms of 15 and 6 have the greatest common divisor 3. So we can divide both the terms of this ratio by 3. Then I'm getting 15 divided by 3 is 5 and 6 divided by 3 is 2. In these two similar triangles, the corresponding sides are in the ratio 5 to 2. From this ratio, we'll be able to get the ratio of the areas of these two similar triangles. Okay, now let me write the stuff over here. That is, to get the ratio of the areas of these two similar triangles, we have to square the terms of the ratio over here. That is 5 square to 2 square. Then I'm getting 25 to 4. So the ratio of the areas of these two similar triangles is 25 to 4, and this 25 is corresponding to the area of the bigger right triangle BCA or ABC, and this 4 is corresponding to the area of the smaller right triangle ECD or CDE over here. Okay, now from the terms of the ratio over here, we will be able to get the area of each triangle. First, let me write the area of the bigger triangle, that is the area of right triangle ABC equals to. Now, to get the area of the two triangles from the terms of the ratio here, we have to multiply the terms of the ratio by the same non-zero number, say x. Now, to get the area of the bigger triangle ABC, we have to multiply the first term of the ratio by the non-zero number x. Then we get 25x as the area of the bigger triangle. Now, let me write the area of the smaller triangle CDE. To get the area of the smaller triangle CDE, we have to multiply the second term 4 by the same non-zero number x, that is 4x. Okay, here we can get the area of the bigger triangle ABC here. So it's a right triangle. Apart from the hypotenuse AC, we can consider the remaining two legs AB and BC as a height and base. That is, we can consider this leg BC as a base of the triangle, this AB as a height of the triangle. Okay, now let me get the area of triangle ABC over here. Area of triangle ABC equals to, the formula is base times height divided by 2. So for the bigger triangle, right triangle ABC, the base is BC, the length of BC is 12. So we can plug in this 12 for base over here. And this AB, this leg AB represents the height of the triangle, its length is 9. We can plug in 9 for h over here, divided by 2. Here 2 goes into 2 1 times and 2 goes into all 6 times. 6 times 9 is 54. Okay, here I got the area of triangle ABC, that is 54. Already we got the area of triangle ABC in terms of x, that is 25x. So this 25x and 54, both of them represent the same stuff, that is area of triangle ABC. We can equate them, that is 25x equals to 54. Now to solve for x, we have to divide both sides of this equation by 25. When I do so, this 25 will cancel out. X equals to, when I divide 54 by 25, I am getting 2.16. Okay, here I got the value of x, that is 2.16. According to the question, we have to get the area of this right triangle CDE over here. Already we got the area of this triangle CDE in terms of x, that is 4x. Now let's plug in the value of x, 2.16 over here. Then I'm getting 4 times 2.16. 4 times 2.16 is 8.64. Okay, here I got the area of triangle CDE. It is 8.64. We find this 8.64 in answer choice D. The correct answer choice for this question is D.